In this problem, we are given two parallel wires which carry currents I1 and I2. I1 is equal to 5 amperes, I2 is unknown. We know that the two wires repel each other, and we know the distance between them is 4 centimeters. And the force per unit length is 2 times 10 to minus 4 Newton per meter. The question is, what is the magnitude of I2 and its direction? So that's part A. Well, first of all, if the two wires repel each other, it means that the directions of currents in the two wires are opposite to each other. So we can choose this current to flow up, so then this current will have to go down so that they repel each other. Well, how about the magnitude? Well, we know that the force per unit length, the interaction of force per unit length between these two wires is equal to mu 0 over 2 pi I1 I2 over d. Now let's calculate for current I2 from here. So current I2 is then equal to F over L 2 pi d over mu 0 I1. F over L is given. That's the force per unit length, so that's 2 times 10 to minus 4 Newton per meter times 2 pi. Distance d is given, that's 4 centimeters, so 4 10 to minus 2 meter. Mu 0 is a constant, 4 pi 10 to minus 7 Tesla times meter over ampere times I1, which is 5 ampere. And this gives you 8 ampere. So the current I2 is equal to 8 ampere. So now we know that the current I2 is opposite to I1 and the magnitude is 8 amperes. Now the next question is, what happens if you reverse the direction of the current and you double the magnitude of the second current? Well, first of all, if we reverse the direction, then the two currents will be pointing in the same direction, which means that the two wires will attract each other. That's one thing. The second thing, if you double the magnitude, it means that the force per unit length between the two wires will double. So instead of 2 times 10 to minus 4, you will have 4 times 10 to minus 4 Newton per meter.